Ready? Go. Does anybody go back and listen to these?
I will. I'll do it tonight.
All right. All right. Operations with functions. This will be one of the easier ones that we do. We may go ahead and do compositions. We'll see. All right. Here's what we have talked about: the hardest of the operations with functions, which is what we just finished. What were we doing? What operation were we doing with functions?
PRCs.
Okay. Before that, but what did we learn before that to do PRCs? Division. Okay. So we will talk about. We'll hit division a little bit. But addition, subtraction, multiplication, and division, mainly the big thing we're looking at, too, is domain restrictions on these. Okay. All right. So, first off, I'm going to do addition and subtraction together, I think, because they're pretty much the same. So, if I define these two functions, let's say f of x is, I'm going to use one out of the book because it'll be easier, x squared minus 4. And g of x is 3x squared plus 7x. First thing I want to look at is individually, are there any domain restrictions here? I feel like we did domain restrictions on combined functions, did we not? I must be thinking pre-cal. I get pre-cal mixed up with y'all. Okay. Do you see any domain restrictions on any of these?
No, that's just moving.
That's just moving, exactly.
Yeah,
But
no restriction.
why are there no restrictions?
Restriction would be equals not.
Restriction would be like if x has to be
Greater than or equal to.
Okay, but what would cause us to have a restriction like that? I'm looking for two things that cause domain restrictions. Mainly two things.
a y-intercept.
A change in the code. The situation. We're throwing stuff out there.
A fraction with an x in the bottom. Have we not talked about this?
No. I think we did.
I feel like we have when we did domain of functions. Okay? If there's a radical, it can't be negative, and if there's a fraction, it can't be 0 in the bottom, right?
Yeah.
Domain restrictions occur. I know we did this. I remember doing it. If you have a fraction, the bottom can't be 0. Bottom cannot be 0. No, that's just a 0.1 and 0.2. And then if you have a radical, it's got to be positive greater than or equal to 0 under the radical. Okay? And so that tells me if I need to restrict x any. I know y'all remember doing this whenever we get to it. But looking at f and g, are there any restrictions on x? Is there anything I need to say that x can't be? No, because I don't have any fractions or radicals right now, okay? Well, we'll worry. Range, we really look at graphically to find that. Domain's really an algebraic thing, but range we usually look at graphically. All right, so addition, subtraction. If I defined f and g here, and I asked you, what is f of x plus g of x, what would you do?
X squared minus 4 plus 3x squared plus 7x.
You would just add them together. And how might I add these two things together? That's exactly right. It is that easy. Combine. Like terms.
Are we supposed to write it greatest to least? Or no, doesn't matter?
What if it does have a domain restriction?
Then the domain restriction of each one would be a domain restriction of the entire thing. I'll show you one. All right, so we are just combining like terms, right? So this becomes 4x squared plus 7x minus 4. And so somebody asked about the domain restrictions. If one of them were restricted, then it would also be restricted in the combined. Because if you, like, let's say that I told you that x could not be equal to 1. here
So
for
you
whatever
need- you
reason.
need something else to tell you there is.
Well, what would happen is you would take the restrictions of F and the restrictions of G and combine them into one set of restrictions for the combined. It's not as hard as it sounds, and I'll show you an example. It's really easy. All right.
Those two by themselves, there are no restrictions.
There are no restrictions. The domain would be all real numbers, negative infinity to infinity.
So did subtraction do the same thing?
Subtraction is the same thing exactly, but the thing you have to do is you have to remember that you're subtracting an entire function. So you would need to distribute the negative sign.
So it's like adding.
Exactly. And then after you do that, then it becomes an addition problem, and you can go ahead and combine like terms. So if I had f of x minus g of x, what I mean by distributing that negative sign is x squared minus 4. I'm subtracting everything in g of x. Okay, so I'm subtracting this entire piece here. So maybe I do like a same change, kind of like whenever we were doing the long division and we had to change all the signs there. It's the same concept here. So if you're a changer, a same change changer, it would look like this because I'm distributing that negative through there, and then I can combine like terms.
Wait, are you just changing the plus sign?
It was a minus, I changed it to plus. Just change the signs on the numbers. All right, so I have negative 2x squared minus 7x minus 4. Does that confuse anybody? Simple, I told you this was easy. All right. Addition, subtraction is easy. That's it for addition, subtraction. Multiplication and division is whenever we start getting into some domain restrictions. Yeah. Yeah. Let me do it with the multiplication or division so you see. You don't usually have them with addition and subtraction, but let me do a couple. You may, but let me do a couple first with the multiplication division, then we'll get into it. All right, let's do multiplication. Multiplication. Remember, whenever you are multiplying terms, and I know that you think you know this, but it's good to put it in here, okay? When you multiply terms, you multiply the coefficients together and you add the exponents. Okay? When you're just adding like terms, you're leaving the exponents alone, but when we multiply, we have to really start watching those exponents. All right, so if I had f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4. Are there any domain restrictions on those two?
No.
No, there are not. Okay, so I'm good to go there. If I asked you to find f of x times g of x, what would you do? Distribute. Somebody said foil. It is it's like a foil. It's more than two pieces in this first one, but it's just a distribute problem. And this should be easy peasy for you, right? X squared, whoa. X squared times 3x is, x squared times negative 4. I'm done with that one. 7x times 3x minus 7 times 4 is, that's right. And on to the last one. That's exactly right. And I know I'm going a little bit fast through this, but I hope that this is a pretty easy concept for you, the multiply. So I have, clean it up here, 3x to the third, negative 4 and positive 21, 17, yep. 17x squared. Negative 28 and 36 would be 8x minus 48. Easy? as we do division on this, unless we can simplify the fraction itself, we're going to leave it in fractional form, okay? So we're not going to go through and do long division or synthetic division or any of the sort, unless it goes in evenly, in which case in these, it's probably not. We're more focused here on the domain restrictions with division. I'm going to go to a new page. I'm going to keep these same f and g, right? So f of x was x squared plus 7x plus 12.
Division now?
Yeah.
Q.
Q?
Sorry.
Oh, bless you.
That's just how I sneeze.
All right. So we had no domain restrictions individually, right? But suddenly when I put them together as a division problem, now do I have any domain restrictions? Why?
Because you have like
I cannot have 0. This cannot be 0 ever. So the question is, what would cause that to be 0? What value would cause that to be 0? 4 what?
1.
7 minus 7. Oh, wait, hold on. We're doing about x squared.
Well, can it be equal, can it be less than 0?
It would have to be like, oh, you just solved it.
It'd be
Just
a-
solve that. Y'all are way overthinking this.
I was trying to do it in my head.
No, it can't be that.
That's what x cannot be, right? I solved it for x, but really what it's telling me is what x can't be. So how do I write a domain that leaves out just one value? Negative infinity to 4/3, u 4/3
Bracket that.
to infinity. You want, the parentheses are causing you to leave that value out. It's saying get as close as you can to that value, but don't actually include
The
that
bracket doesn't
value.
include it.
Exactly.
Hold on. I'm confused.
Okay, where are y'all confused?
Why is, like, how do you see a 0 in 3x minus 4?
Well, you're not, but you're saying, do I have anything that x can't be? Because domain looks at all x values, right? So is there anything x can't be? Well, anytime I have a fraction, the bottom can never be 0. So I can't say that I could use any x value, because there's something that would cause that bottom to be 0. So to find out what that something is, I set the bottom equal to 0 and solved it. So if you plug 4/3 in this, you'd get 0 on the bottom, which is undefined. So I want a domain that gives me every single value except that one.
Can it be less than 0?
Yeah, sure, it can. Radicals are what can't be less than 0.
I thought it was because there wasn't an x squared that there was a 0 in place of the x squared. That's what I was confused about.
No, listen, here's the thing. Even if something happened, like let's say I had x plus 5 over or times x minus 2. Let's say it just factored. Okay? Let's say that was my combined function. Even though this simplifies down to x plus 5, I still, because it was defined this way to start with, x still can't be positive 2. So yes, this is my new function, but my restriction still stands, x can't be 2. Okay? So even if it simplifies down, you have to look at the very original to see if there is any restriction there on the domain. Does that make sense? No, well, you're finding the function and any domain restrictions it may have. Uh-huh.
No, because it doesn't.
Probably put this in the
Does that
video.
actually be
It's a good question. If I had, let's say I had 3x plus 2 over 3x minus 5. You cannot do that. Okay? Because it's not being multiplied. The only time things cancel is when you're multiplying. I'm going to put a big no. Okay? So if it was 3x plus 2 times x minus 5 over x plus 2, x minus 5. These whole things can cancel out now because I'm multiplying. The rule of thumb is every plus or minus needs to be in parentheses, inside of an operation with parentheses.
So then,
That way,
so his answer is
The answer
3.
is the problem you started with?
3x plus 2 over x plus 2. Those can't cancel.
Why?
You'd still have the restrictions from both of these. X couldn't be negative 2 or 5 on this one.
So for the other one, with the original problem, you see the answer?
Yes. Well, whenever you put them in a fraction form, yes.
If there's two restrictions, how would you write the?
All right, so if this one, if I were doing domain restrictions for this one, x cannot be negative 2, right? But it also can't be 5. Because that's what happened if I set the bottom to 0. Think about set each factor to 0 and solve, right? So to write this, I would go negative infinity to negative 2. Pick back up at negative 2, go to 5, but stop at 5, and then go from 5 to infinity. Every time you leave out a number, it's a back-to-back parenthesis. Yeah.
So I get that, but then for the other one, the x squared plus 7x plus 4, what do you do to get the final equation?
You put them one over the other, f of x over g of x.
Yeah, but then.
What we had was the final equation. Yes. Yes. Let's see.
Please, no.
The last operation we're going to talk about is composition. And so, yeah.
Wait, is this the next thing?
If you do this now, you'll have double as many questions as you did right.
That's okay. I can handle them.
No, I don't know. But we can't handle them.
So what's up with that?
All right. Composition is not a hard concept. You just have to, if you understand plugging in, then you'll understand composition just fine, okay? In other words, if this is my f and my g, right? If I asked you to find f of 2, tell me what you would do.
Plug in 2 for x.
You'd plug in 2 for every x and f, right? So I'd have 2 squared minus 4, which would be 4 minus 4, which would be 0. What if I asked you to find f of k?
You plug in k?
2xk plus 1k.
F of k.
So I do k squared minus.
K squared minus 4, and that's it, right? What if I asked you to find f of...
Wait, back up.
Okay.
Which problem are we?
I'm going to use the other one in just a second.
Why do you have a 4? That's for f.
That's for f. This means the way this is written, whatever is in parentheses, I plug in for every x in the equation it tells me here, okay? So what if I said, what is g of x plus 1?
2x squared plus 1.
You plug in x plus 1. I look at the g equation this time. So it'd be 2. It's not x anymore because what I'm doing is I'm replacing the x with x plus 1 plus 1. And then I could clean that up a little bit, right? I could distribute and combine like terms. 2x plus 2, which would be 2x plus 3, right? If you can understand that concept, you can compose functions. And I'll hold up just a minute and let you catch up. Take these same two. I'm going to keep referencing these two because it'll be easier than rewriting them or than coming up with new ones each time.
We're doing composition.
Composition. This is still, I was just kind of leading up to composition.
Is that all composition?
So what composition is, what if I wrote it as this? I said, what is f of, and instead of f of something, I've got f of g of x. So that's exactly right. The key to composition is to work inside out, okay?
This was a question, this was a
Yeah, and I thought it.
On the PSAT or whatever.
Yeah, I really thought about it. Yeah,
It makes sense, right? if I sit here and go, okay, well, wait, g of x is 2x plus 1, right? Inside out. So now, if you understand that whatever's in parentheses just replaces every x, okay, well, that means I have 2x plus 1 squared minus 4. You see it? So now this becomes, I can't distribute that because I'm adding in the parentheses. I have to FOIL this out. So I get, come on, 4x squared plus 2x plus 2x plus 1 minus 4, which cleaned up looks like this. Easy.
Why does it become squared?
2x times 2x. As you copy that down, there's notation that a lot of, I like f of g of x, but just to show you, because I think your book doesn't use this notation. This
Oh, yeah.
is also notation. It means f of g of x. Okay, and it may do this. Looks like fog. Okay, that is the same thing as f of g of x. What did they use on PAC?
They
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 used
put
the.
brackets and then the X was in.
I got you.
Yeah.
So it really doesn't matter. You just have to be able to recognize both.
So composition is just like f of another plugging.
Yes. Okay. Now, let me kick it up just a little bit.
Yeah. Pick it up. Oh.
Let's take it down.
Pick it down.
Let's take these same two. What if I asked you to find, I'll make this one easy. Can you do it?
You squared, maybe.
Well, you're not multiplying them.
Plug in plus 2 of x for x.
So you're literally plugging in. So I take it again and I say, okay, I've got 2. It's not x anymore, it's 2x plus 1. Plus 1.
So you plug in g of x for g of x?
Yes. You plugged in g of x for x in g of x.
So you're just plugging in something for
Exactly. 4x plus 2 plus 1, which is,
Wait, so in the last one you said when you have things squared, when you're adding it, you can't like distribute the envelope without this x bar? Yeah. Yeah, you have to
no, you'd have to write it twice. Because if you're adding or subtracting inside the parentheses, it becomes a FOIL problem. How about this?
like you said something.
Which could also be written as that. Fog
So you
two.
plug in
Remember, I told you the key to composition is working what?
inside out.
Inside out.
so you're plugging in 2 for every.
So the question is, what is g of 2?
It's just x over 2 is g of x. So it's just do like 2 times x.
Yeah, absolutely.
Wait. So you're just plugging g into what?
Well, this time I'm plugging 2 into g, and I'm getting an answer, right? So I know g of 2 equals 5. Are we all in agreement with that? And if g of 2 equals 5, then really what I'm finding is not f of g of 2, but f of 5. Because g of 2 is 5. So 5 squared minus 4.
Wait, Miss Phoebe, can I just write it as like 2 and then parentheses 2 plus 1 and all of that squared minus 4?
Sure, you can do it all at one time. Questions? Almost. Oh my goodness. Yeah, it's a little tidbit. If you plug in a number, you should always get out a number. Okay, so like the one where we did f of g of, what was it, 5? Or f of g of 2, because I'm plugging in a specific value, I should get a specific value out. If I plug in a variable, I should get a variable back out, okay? Now, if I define, I'm changing how I'm defining f and g. I'm defining f as a relation, as in a set of points, not an infinite set of points, not an equation, but a set of points. Same thing with g. So what if I asked you to find f of g of x? Okay. Do you understand that what I'm asking you for is not an equation, but a set of points, right?
So are you,
So what? Are you asking for the x line?
So look at what I have to do.
so do you have
You would do 8, 5, 10, and 9 again, right?
That's exactly right. That's exactly right.
Wait, why do you all?
what she
Those
said?
are the x's.
The X is
Wait, what are we
G.
plugging
That's right.
in?
All right, so look, I've got, really what this is saying f of 1 equals 8. F of 0 equals 13. F of 15 equals 11. And f of 14 equals 9. Right? And in turn, this one is g of 8, come on. G of 8 equals 15. G of 5 equals 1. G of 10 equals 14. And G of 9 equals 0, right? So what I have to plug in is I have to plug in all the x's for G, right? So I'm going to do f of G of 8. I'm going to do f of G of 5.
And we're plugging that into the G of X.
F.
2X plus 1.
F of G of, come on, 10. And f of G of 9. Right? Yes, you do.
So 17.
What do we do?
Well, 17.
Correct.
Okay? All right, so here we go. What is G of 8? Remember, inside out.
So that would be 11.
What is G of 8?
17.
It's 15. What is f of 15?
Wait, but you plug that into the 2X plus 1, you get 17.
No, I'm different f and g's. This is a whole different example.
Okay.
Okay,
So we're not
no
using
equations.
No, f of 15 is 11.
F of 15 is 11. So what are the coordinates of that point? 8, 11. See what we did here? You gotta write it down. You gotta write it down. All right, so f of, what is g of 5? 1. And f of 1 is, so what is that point? Does everybody see what we're doing?
Yes.
How we're finding f of g of x? All right, what is g of 10? 14. What is f of 14? You see, you couldn't do this if this wasn't a tailor-made set of points because it's coordinating very nicely for us, as it should. And then g of 9 is 0. G of 9 is 0. And then f of 0 is 13. All right, I forgot to write this point. 10, 9, and 9, 13. So just like this is what f is and this is what g is, this all together is the composed function.
Now that I look at it, it makes sense.
It does. It makes sense. I feel like it especially makes sense if you do this.
Yeah, because just plug it in.